This is question number 4. The population of bacteria in a pond is P thousand D days after the pond is filled. It is known that P equals to D cubed minus 12D squared plus 45D. Find the highest population of bacteria in the pond in the first 4 days after it is filled. So for that, what we need to do, since we need to find the highest population of bacteria, so we do its differentiation with respect to d, derivative with respect to d. So that will give me 3d squared, then 12 times 2d, the derivative of d squared, and then derivative of 45d, that is going to be 45 times 1. So we can write it down as 3d squared minus 24d plus 45. This is the derivative of p with respect to d. Now, to find the highest population, what we need to do, we can put dp by dt equals to 0. That means we are going to put 3d squared minus 24d plus 45 equals to 0. Now this is a quadratic equation, so we can take 3 common, d square minus so d square is equal to, now we need to have the prime factorization of this 15, which could be negative 3d minus 5d. So now let's combine these two. Taking d common, we get d minus 3, and from here we take 5 common, so that's why it is d minus 3 again. That will give us d minus 3 times d minus 5 equals to 0, which will give us finally d equals to 3, and then d is equal to 5. So now when we have got these two values of the days, in the first 4 days after it is filled, when we will be replacing d equals to 3 into this uh, population term, that would be find the highest population in the first 4 days. We have to find it out for first 4 days. So that will be after 3 days. So 3 raised to power 3 minus 12, 3 raised to power 2 plus 45 times 3. This is 27 minus 12 times 9 plus 135. So we can have it positive 162, and this is so subtracting them up, 54. Now, since p was there in thousands, So 54,000. D is equal to 54,000. That is for the bacteria to be maximum, because we had to find out the population for the first 4 days. That means after third day, we are going to calculate it for D equals to 3. So that is question number 4. Okay, now it is question number 5. A manufacturer makes open topped boxes by taking a 2 meter by 1 meter sheet of metal, cutting x meter by x meter squares out of the corners and folding along the dotted lines shown in the diagram. Show that the volume of the box produced is given by V equals to x times 2 minus 2x and times 1 minus 2x. Okay, when the box is going to be made like this, it would be made something like this, and its height is going to be like this. That means the height is going to be this x. When this will be folded, this would serve as the height of this box. Okay. When you see that the length is this one, which is 2 meters, from 2 meters along the length, one x has been cut from this side and another has been cut from this side. So length would now be 2 minus x minus x. That would give us 2 minus 2x. And from the width, 1x has been cut from here, from the bottom, and the other x has been cut from the top. So width is also 1 meter minus x minus x. That is 1 minus 2x meters and meters. And for the height, this is going to serve as the height when this will be folded upwards. So height is going to be x meters. So now for the volume, length times width times height. Length is 2 minus 2x times width is 1 minus 2x times height, that is x. So that is the volume as given. Okay. Now for part B, explain why x must be less than 0.5 meters. This is because as you see, for the width that was 1 meters. So the portion that is being cut, if this is 0.5 meters from this side and 0.5 meters from this side, so all the width would be cut. So that means the portion that needs to be cut, that should be lesser than 0.5, so that when you just cut this portion from the above and the bottom, the remaining should be some value lesser than 1 meters. So for part B, we can write down as width is equal to 1 meter, and we are cutting x plus x, that is 2x from it. So x must be lesser than 0.5 meters. Okay. Now for part C, find the value of x that will give the maximum possible volume of the box. Okay. For that, what we can do is that we can simplify this volume expression first of all to have 2x minus 2x squared times 1 minus 2x. I've just multiplied x with these two. So the volume is now 2x minus 4x squared, then minus 2x squared, and then plus 4x cubed. And now simplifying and arranging them further, 4x cubed minus 6x squared plus 2x. Now we can find its derivative, dv by dx, that is 4 times 3x squared minus 6 times 2x plus 2 times 1. That will give me 12x squared minus 12x plus 2. So now to have the maximum possible volume, we need to put dv by dx is equal to 0. So that's why we can have 12x squared minus 12x plus 2 equals to 0. From here, now we are having 2 can be taken out common. 6x squared minus 6x plus 1 equals to 0. And from here, we can apply the quadratic formula to have the values of x. Two values of x would be got from here. That would give me one value that is going to give me 0.79, and the other value of x would be 0.21. We have applied the quadratic formula. X is equal to negative b plus minus b squared minus 4ac divided by 2a, where the values of a being 6, this is a, this is b, and this is c. B being negative 6 and c is equal to 1. Okay, now we have got these two values of x. We need to find the value of x that will give the maximum possible volume. Okay, for the maximum possible volume, we can replace volume at x is equal to 0.79. That would be, I'm going to replace the value of x in this expression of volume, 0.79 times 2 minus 2 times 0.79, and then 1 minus 2 times 0.79. using the calculator, or we can also replace that value into this simplified expression as well. 0.79, then minus 6 times. I'm going to replace it in this relation because that would make it a bit simpler to calculate. 2 times 0.79. In this case, the volume is becoming negative 0.19. And if now we calculate the volume at x is equal to 0.21, this other value of x. So that will give me 4 times 0.21 whole cubed minus 6 times 0.21 whole squared, and then plus 2 times 0.21. No matter you replace the value of x in this equation or in the given one, the one that was given in the start of the question. So in both the cases, you'll get the same answer because this is the simplified form of the same expression. So this is going to give me 0.19 meter cubed. And if you compare these two values, obviously this is greater than the volume value calculated previously. So the value of x that gives the maximum volume is this one. So volume max is for x is equal to 0.21 meters. So that completes question number 5. It's part C.